On May 31st, North Korea attempted to launch a military reconnaissance satellite using a rocket, but the mission ended in failure. Instead of successfully reaching orbit, the satellite ended up crashing into the West Sea, leading to a highly publicized embarrassment. Despite this setback, North Korea's space agency indicated its intentions to potentially retry the launch, highlighting the strategic significance of such satellites. In the contemporary global landscape, it's not just North Korea, but numerous countries around the world are actively working to acquire reconnaissance and intelligence satellites. Today, we'll delve into understanding the functioning of reconnaissance satellites, history and future prospects of reconnaissance satellites. During the Cold War, the United States was on a mission to find out if the Soviet Union was developing intercontinental ballistic missiles, ICBMs. Unfortunately, they faced interference and couldn't get the information they needed. However, a game-changer emerged in the form of reconnaissance satellites, thanks to the rapid progress in space technology. Reconnaissance satellites became the go-to solution for secretly keeping tabs on enemy nuclear missiles without having to enter their airspace. These early satellites were equipped with high-powered cameras and capsules to store film. Interestingly, they couldn't transmit information using radio waves back then, so the film had to be dropped at a designated spot for retrieval. As technology evolved, semiconductors and CCD, charge-coupled device, technology emerged. This allowed for the direct transmission of detailed images. These satellites are made from unique materials that don't reflect light, making them stealthy. They typically orbit Earth at around 1,000 kilometers above the surface. When they need a close-up view, they change their orbit, descending to a few hundred kilometers to capture precise images, even inside buildings. Then, they return to their primary orbit. Unfortunately, due to the high fuel consumption from these trips, their lifespan is relatively short, often lasting only a year or less. Nevertheless, they're incredibly valuable because they operate within international laws, avoiding airspace violations while providing critical information. Recent advancements in artificial intelligence, AI, have further improved their capabilities. AI can enhance high-resolution telescope images, producing results nearly identical to the original. However, there's a new challenge on the horizon: the killer satellite. The U.S. government is actively developing laser weapons designed to take out reconnaissance satellites. These killer satellites would fire continuous laser beams to destroy their targets. In future conflicts, we might see killer satellites in space, armed with laser cannons, targeting the reconnaissance satellites of enemy nations. So, while reconnaissance satellites are exceptional tools for gathering intelligence, they could soon face a formidable adversary in the form of killer satellites armed with powerful lasers.